Hi.
Hi. Are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way.
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi. Are you sure you can prepare for product-based companies through this course?
Yes, sitting at home?
No way.
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Oi. So they give access to their job portal, Geeks for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way.
Oh, yes ways. Don't delay. Enroll now.
Geeks learning together.
Hi, very good evening, everyone. Welcome back to this dynamic programming session. And today we are yet again back with another amazing session that we are going to conduct, which will be based on DP. And before we proceed, can I please get a quick confirmation if my voice is clearly audible and also if my screen is clearly visible? I will just share my screen. Okay, so hi, Naikaj. Hi, Himanshu. All right. Okay, everyone. So thanks for the confirmation. All right, it is echoing. So
All right. Is it clear now? Yeah. Is it still echoing or are we good to go? Still echoing? All right, good to go. Okay, thanks. All right, let's just wait for a couple more minutes, okay, so that rest of our friends also join, and then we shall be starting. So last day we were not able to conduct this session properly because of this voice issue, but today I fixed it. So let's just hope that we will able to finish our today's session. And till then, let me just give a review of what we are going to do today. So, all right, this is our dynamic programming series. So, okay, today we are in the previous class we did LCS. So, today what we are going to do is today we are going to learn about problems based on LCS. Okay. In the previous class, I hope all of you remember it, we discussed about longest common subsequence and longest common substring. All right. So they are going to form the parent problem of all the problems that we are going to discuss today. Okay. So, all right, how to master recursion? So that's a very good question because for DP, the parent concept that is involved in DP is recursion only. Like entire DP is based on recursion. DP is basically an optimal recursion. So if you want to master recursion, then right, what you can do is you can practice questions. So like in Geeks for Geeks, we have lots of questions. And what you can do is you can filter out the questions that are based on recursions. And there are certain things, actually, see, recursion is not that tough. Let me tell you about some of the points that you need to keep in mind while you are doing recursion. So the first thing, first of all, just think about the base case. All right, base case is what? That is the smallest value of input that you can give. Okay. Okay, so base case is the smallest value of input that you can give. And second thing you need to take, you need to keep in mind is once you have this base case, you need to find out like, condition, basically condition as in like, what are the choices that you are making. All right, like if there are choices, then it can be like two recursive calls, or there can be only one recursive call, two recursive call that we have in Fibonacci, and then one recursive call that we have in uh, like it can be any case. I don't remember any case right now for one recursive call, but then you just need to think of a base case, and then you need to keep on decreasing the value of input. Okay, and then just keep on adding the steps that you will need to do based on the choices that you make. Okay, so keep these thing in mind. You can just practice recursion. And yes, another thing is that key to everything is practice. Do more practice. The more you'll practice, the more you'll get better in these things. Okay, so I think we are good to start. Let's just not waste time. All right, so the first question that we are going to discuss today is longest palindromic subsequence. All right, so just okay. All right, Himanshu, can I say again what? Longest palindromic subsequence, like about that recursion thing. What I said is we need to keep two things in mind, that is base case and the choices that we are going to make. What I mean by base case is smallest value of input. What I mean by that is, let us say if you are writing a recursive code for Fibonacci. Okay, so some of you may have this confusion in what is the smallest value of input. So let us say we are writing this Fibonacci for n. So what will be the base case that you write? If n is equal to 0, or if n is equal to 1, you will be simply returning n, right? So that is the smallest value of input. What I mean means, what is the least value of input that you can give to your n? Okay, so least value of input that you can give to n is either 0 or either 1. Okay, let us say you are writing recursive code for any array. So in that case, what you will be writing as the base case is, if size is less than 0, right, means the last value of size that you can give to your array is 0. Okay, so that's why this is known as the smallest value of input that you can give. Okay, in this way you can write the base case for your recursive code. Okay, all right, and now we are moving for the introduction part. So we are going to study today longest palindromic subsequence. What we did in the previous session was we discussed about longest palindromic subsequence and longest common subsequence and longest common substring. Okay, that was done in the previous session. So today these two concepts are going to form the parent concept of the questions that we are going to discuss today. All right, so okay. All right, that's great, Himanshu. So longest palindromic subsequence. Now let us know about what can be our input statement. Okay, so the input statement, that is, let me check in the question. Okay, so this is the input string that is given to us, and in that the longest palindromic subsequence that we have is B A B C B A B, right? Yeah, right. Okay, so as you can see, the output that is going to be B A B C B A B. Okay, this is going to be our output, and in output we need to return the length, so we will be returning 7 because the size of the string is 7. Okay, so in the input statement a string will be given to you, and in the output you need to return the length, that will be an integer value. Okay, yes, I meant the subsequence because this is longest palindromic subsequence. And what do we mean by subsequences? It need not be continuous. Okay, it can be discontinuous as well. Cool. We have this question for longest common substring also, like yeah, we have this longest common substring, but in that question you don't need to use the concept of DP. Okay, that question can simply be solved with the help of normal traversal forward and backward, right? So longest common substring, that's not a DP concept. Basically it can be solved with other concept as well, so we are skipping it here, and we are going to discuss the longest common longest palindromic subsequence. Okay, longest palindromic substring, you can do it without DP as well, right? Okay. So yeah, here we have this thing. In output we need to return. Okay, so the input statement and output statement is clear to you all. In input a string will be given to you, and in output you need to return the length of the longest palindromic subsequence. Okay, subsequence, keep that in mind. It can be discontinuous set of characters. Okay. Yes, exactly, Shubham. 2 pointer is enough for longest palindromic subsequence. Sorry, longest palindromic substring. Okay. Discontinuous set of characters. Okay, everyone. All right. So, input output clear to you all. Please give me a quick +1 in the chat section. And yes, by the way, a very happy Republic Day to all of you. And happy Saraswati Puja as well. Let me just write it down. And also, if at any point of time my voice is not clear, please do let me know that as well, okay? We have happy Republic Day, everyone. And happy Saraswati Puja as well. Okay? Alright, voice is clear. Great. I fixed all the issues today to just make sure that no any such mishaps happen again. Okay, so let's just move ahead. So, okay, we got a +1 from the people, so we are good to go. And thanks to everyone for those who give +1 in the chat section. It gives the confirmation that if we can start the next topic or not. Okay, so all right, let's just now see the string that was given to us was B, B, A, B, C, B, C, A, B. Okay, we needed to find its longest palindromic subsequence. Okay, now tell me one thing. Okay, first of all, it is a subsequence, okay, which means that it need not be continuous. Now, as I said, the parent problem to this problem is LCS question. Okay, so now you need to find out the relation between LCS and LPS. All right. So, okay. Include exclude type of DP, actually include exclude, yeah, like the DP is basically the choices. That entire DP concept is based on the choices that we need to make. So obviously this include exclude is going to be there. And now with including and excluding, like with including plus excluding, what you need to do is you need to find the most optimal answer, right? We need to find the length of the longest palindromic subsequence that we can have, right? So okay, as the parent problem is LCS, so as we both all know, in LCS what happens is that we had two strings, right? And in those strings we were finding the longest common subsequence. Okay, so as it is longest palindromic, so just a minor observation that all of you can do is, and with that minor observation you will be able to write down the code to this question. Okay, now let us say if this is our string, let us say if I am doing this reverse. Okay, so the reverse of the string is going to be B, A, C, B, C, B, A, B, B. Okay, this is going to be the reverse of the string. Now let us say we need to find out the longest common subsequence between these two. Okay, so everyone in the chat section, please quickly tell me what will be the LCS of these two strings. Let me also figure it out. This is common, this is common, this is common, this is common. Yeah, this is common, this is common, this is common. Okay, so yeah, this is B, A, B, C, B, A, B. All right, so we have one answer here, that is BCB. So actually that is a common subsequence, but that's not the longest common subsequence. So here we are aiming towards finding the longest common subsequence. Okay, so I want you all to look carefully into the string that I have given, and please let me know what will be the LCS. All right, and also all of you can try to find the LCS of your names as well. Like, sorry, LPS of your names. Okay, once we will be done with the code of this question, I want you all to write down the LPS of your names. Okay, let us see if any of us have it. Why no any answers for this question? What will be the LCS of these two strings? We have discussed it, right? Is there any confusion, guys, for LCS thing? Um, I'm audible, right? You had that doubt as well. Yes, I'm audible. All right. Yeah, all characters are different. So basically, LPS will be one. Yeah, LCS will also be one. Okay. So all right. So the LCS of these two strings are going to be this. Okay. Now tell me, uh, are you guys able to observe this thing that LCS of string and its reverse is equal to LPS of the string? Is this concept clear to you all? Yes, Shravan, Shubham, that's the right answer. Alright, so is this thing clear that LCS of a string and reverse of the string is equal to the LPS? Not clear? See, what is happening is that in longest palindromic subsequence, we have only one string, right? But in LCS, we have two strings. So you need to figure it out that how you can convert this LPS into LCS. So we need two strings, right? So those two strings are string and the reverse of the string, okay? Because when you will write down the string, when you will write down its reverse, and you will aim to find out the LPS, sorry, when you will aim to find out the LCS of these two strings, you will get that is equal to the LPS, right? So the observation here is that LCS is going to be the LPS, okay? LCS of string and its reverse is going to be the LPS, okay? So yeah, that's the observation. So now let's just jump towards the code. And all right, so code is not visible, right? Let me just do something. Yeah, so this is the code to this question, and I want you all to look in the code and do let me know if any section of this code is not clear. Okay, so basically what we have done here is we have taken the string that was given to us was s1, and we have reversed the string, okay, and the string s1 was stored in s2, and then we reversed it s1. Okay, so basically we have two strings here, s1 and s2. We simply wrote this code of LCS. Okay, this is simple code that we have written for LCS, okay, longest common subsequence. That's why we have written here as max. Okay, or else, okay, let us see how many of you remember the previous session. If it would have been the substring, then how we could have replaced this? In the case of substring, the line number 30 is, can't we use two pointers on str and reverse str to get LPS? No, actually two pointers will not help because we are working on subsequences. Okay, if you could have worked on substring, then in that case two pointers can help you, but in this case two pointers can't help you, so we need to use TP here. Okay, so everyone, please do let me know in line number 30 what it would have been if we were discussing about substrings, longest common substrings. And there should be at least two or three correct answers because we have discussed this thing very clearly in the previous sessions. Alright, so I'm waiting for your answers. Okay. Alright, so none. Alright. Hi Shagun. And yeah, that's the correct answer. T of ij will be 0. Okay. So that's the only correct answer in today's session, and that's really impressive. And I want all of you to please pay attention towards the sessions, okay? That will help you to clear out your concepts. Otherwise, if you will just keep on, attending the sessions, and then if you will forget what I did in the previous session, then it might cause problems in understanding the concepts. All right. So if it would have been substring, then T of ij would have been 0 here, okay? But we don't have a substring here, we have a subsequence, so we are replacing it with the max value, okay? All right, is this code clear to you all? Please give me a quick +1 or thumbs up so that we can move towards the next code. Thanks, Shubham. Thanks, Mix. Share this code. All right, Nikes, I will be sharing these codes towards the end of the session, okay? All right, so the concept is clear to all of us. So let's just now move to the next question, and that is, okay, so the next question that we are going to discuss today is, let me just check it, minimum number of deletions. All right. Minimum number of deletions to make a string palindrome. All right, everyone. So as I said, the parent problem for all of the questions that we are going to discuss today is the LCS question, okay? So if any question that is occurring in this session, I want you all to find a relation between this question and the LCS concept, okay? Because all of these questions are based on the LCS concept only, okay? LCS concept is the main concept, okay? Parent problem, we can say it, that we have for all the questions, okay? So basically we need to find a relation between these two, okay? So again, only a single string is given to us, where in LCS we have two strings. So now let us see, is there any connection between these two, or do we need to head towards any another approach? All right, so let us say the string that is given to you is A, E, B, C, B, D, A, okay? Yeah, so before moving ahead, all of you please tell me the longest palindromic subsequence in your names. Okay, I'll write in mine. Longest palindromic subsequence is ITI. In my name, it is ITI. Alright, I want you all to post the longest palindromic subsequence in your names. We might have very few names with longest palindromic subsequence. Let us see if we have any. We don't have any AIA. Okay, correct. So like it is 3. Like yeah, 3 is correct. So we have any string of length greater than 3? Naman. Himanshu, that's the correct answer, but actually I asked that if there is any LPS in your name. Length of LPS in your name. Like that's the question that we are discussing. So we don't have any palindromic names here, right? HUH, HPH. Yeah, correct. Okay, so I guess 3 is the maximum length that we have in our names. Okay, that's great. All of you can keep on posting the strings that you get in your answers. Till then, let us move to our next question. Okay, so a string is given to you all, okay? Now, what you all need to do is you need to find out the minimum number of deletions that you need to do to make that string a palindrome, okay? So, in this case, this is the input, a string is given, and output that is going to be a string, sorry, an integer, and that output is going to be uh, that output is going to be, let me check in the code. that output is going to be 2 actually, okay? So 2, okay? Now why 2? Basically what we are removing, if you remove E from here and if you remove D from here, what you are going to do is you will get A, B, C, B, A, which is a palindrome, okay? Yes, Shubham, that's the correct answer. It will be length of the string minus length of the LPS, but then let's just devise how we are going to have this equation, okay? Let's just find it out. So, all right, we are doing 2 deletions and the string that we are getting is ABCBA, which is a palindrome. All right, everyone. Now, okay, 2 is not the only answer that we can have for this question. Other answer could have been like, let me use a new page. Let us say the string was A, E, B, C, B, D, A. Okay, this was our string. Now let us say what we are doing is, let us say we have deleted from here. There is one more. There is one more palindromic subsequence that we have here. Okay, which is A, B, B, A. Okay, I'm getting this A, B, B, A. Okay, now this is the number of deletions. Number of deletions that I have done here is how many deletions? If I'm writing A, B, B, 1, 2, 3. 3 deletions, okay? And size of the substring is 4, okay? Now, okay, another deletions that I could have done is, let us say if this is A, B, B, A, then another, it could have been the answer that we have, that is A, B, C, B, A, okay? A, B, C, B, A. Okay? In this, the number of deletions that we are doing is 2, and size of the string that we have is, size of the resultant string that we have is 5, okay? Let us see another deletion that I have done is I have deleted all the strings, so, all the characters except for one character. I can do that, right? Let us say I have deleted all the characters and only characters that I am left with is say B, all right? So the final string that I'm getting in my answer is B, and number of deletions that I have done here is I have deleted all the characters, so 1, 2, 3, 4, 5, 6, and size of the subsequence that I'm getting is 1. Okay, so in all these cases, there can be multiple cases like this, okay? So in all these cases, you might have observed this is a palindrome, this is a palindrome, this is a palindrome as well. But then we need to find the longest palindromic subsequence, right? So for the longest palindromic subsequence, as you can see here, this is the longest palindromic subsequence, and in the longest palindromic subsequence, the size of the subsequence is largest. By what do I mean by the largest size? In this string, LPS will give you the longest palindromic subsequence, right? So as you can see, the number of deletions, and okay, all of you are able to observe this number of deletions is inversely proportional to size of subsequence. Lesser the number of deletions, okay, greater the size of subsequence, right? So if you want to find out the maximum size of if you want to minimize the number of deletions, right, if you want to minimize this, then what you'll have to do, you'll have to maximize the size of the subsequence. So what can be the maximum size? It can be LPS. LPS is anyways going to be the longest palindromic subsequence, so that is the maximum length of subsequence that you can have, right? So basically number of deletions is, and also are you guys able to observe this one more thing, that is 4 plus 3 7, 5 plus 2 7, and 6 plus 1 7. What do I mean by that is, okay, number of deletions is equal to size of string minus length of LPS. Okay, is this equation clear to you all, and all the three concepts that I just explained? Let me repeat. The first concept that I said is number of deletions is inversely proportional to size of subsequence. The second concept that I said is that number of deletions plus size of subsequence is going to give you the total length of the string. And thus we arrived at this, that if you want to minimize the number of deletions, you'll have to maximize the size of subsequence. Thus this equation, okay? So please give me a quick +1 and thumbs up in the chat section if this equation is clear to you all. All right, Shubham, if you want to get the palindromic subsequences, then for that what you need to do is you will, whenever in like the table, the 2D matrix that you are performing, whenever you are inserting, like whenever you are considering that current character in your LPS, you need to keep track of what character you have considered. All right. In the matrix, you can use any kind of marker sort of thing that it can mark that this character has been added in your LPS. Okay. So later on, what you can do is you can revisit those marked characters and you can print it. And anyways, we can take up these questions in our next session as well if you want me to. Like we can print the longest palindromic subsequence, we can print longest common subsequence as well. Okay, those things can be taken up. But as I said, you can perform these things just whenever you are having a 2D matrix, just keep on marking whenever you are inserting any value, whenever you are inserting any character in the LPS, you can just mark it that these characters have inserted. If it is clear, then it's fine. Otherwise, we'll take up it in the upcoming sessions. Okay. All right. Is this equation clear to you all? Please give me a quick +1 in the chat section. And also, I hope my voice is clear till now. Thanks, Nix, for the confirmation. If any of you want me to repeat any of the concepts, I can do that. Please feel free to drop your comments in the chat section. Yeah, all right, Shubham, we will be taking it up someday to get more clear. And also, let me inform you, everyone, as we have already discussed two of the concepts, two of the parent problems, that is knapsack problem and LCS problem. So what we are going to do is in tomorrow's session, we will be having some practice questions, okay? Like I will give you homework, 3 questions. Thank you so much, Nix. That means a lot to me. All right, so I will be giving you 3 questions, okay? That 3 questions, I want you all to practice it, okay? And in the tomorrow session, we will be discussing those 3 questions, okay? Because we have 2 sessions per week, and I don't want to start any new concept in the ending day. That's why, no, that's not a 30 days of challenge. It's just that after covering some concepts, like 1 or 2 concepts, we will be doing some random practice questions, okay? Because DP is all about practice, right? The more questions you will practice, the more clearer it will get to you. All right, so we all are clear on this equation. So let me just share my screen. Okay, let me just do one thing. Okay, so yeah, this is the code that we have for minimum number of deletions. Whiteboard software name, this is OneNote by Microsoft. So this is the code. What I have done here is we needed to find the minimum deletion. So simply we are returning the size of the string minus longest palindromic subsequence. And this is the code to find the longest palindromic subsequence. It was simply the longest common subsequence between the string and its reverse. Okay, please have a clear look at this code. And if there is any issue, do let me know. Yeah. The size is okay, right, of the code font. All right, thank you, Shubham. So guys, I think we are good to go to our next question. Okay, so we are good to go. So our next question is, yeah. All right, so minimum number of deletions and insertions. Okay, so let's just study about this question. And the question statement reads as, so what is happening here is that 2 strings are given to us and the task is to remove or insert the minimum number of characters from string 1 so as to transform it into string 2. Okay. So it could be possible that the same character needs to be removed, deleted from one point of string 1 and inserted to some other point. Alright, we need to make the two strings same. Okay. So we have two strings here as heap and p. Okay. And what we are doing is we are deleting two characters from heap, that is p and h. After that it will be ea, and we can insert p here so that it can be equal to pea. Okay, so that is going to be the answer to this question, like 3, because total number of 3 operations have been performed. Now let me write it down. Okay. Minimum number of insertions and deletions to make both strings equal. So how will the problem statement look like? In problem statement, an input will be given to you which contains of two strings, that is heap, that is p. Okay. And in the output, you will be returning an integer that will be the minimum number of operations done. Now, as you can see, there is HEAP, it is PEA. Okay. The output of this question, you can delete H, this will become EAP, still not equal to PEA. So you can delete P, it will become EA. Now you can add P so that it can, have some more length as well. So when you will add P, so how many operations you have done? This is number 1 operation, this is number 2, and when you have added P, that is 3. So total number of operations done is 3. So that is the answer to this question. Okay. So is the problem statement and the output clear to you all? Yeah, you can insert any number of characters, but just make sure that you are able to get the maximum length from it. Okay. And the operations are numerous. Yeah. So yeah, all right, next, that's the correct observation. So let's just try to find out that equation. Okay. And that's great. I'm very much happy to see all these correct answers. It means that all of you are really practicing. All right, guys. So input statement, we can swap, right? No, actually swapping is not going to work, because what we are trying to do, like what swapping, I mean, what kind of thing are is trying to do? All right, m and n, m is the size of one of the strings and n is the size of the string 2. Sizes of the string. All right, let me now help you with this observation. Okay. So when the two strings are given to you, don't just, I mean, all of you can carefully look into this thing that I'm telling you. Okay. Yeah, you can use whatever approach you want to do, top down, bottom up, everything is fine. Okay. These two strings are given to me. Okay. Now tell me, what is the LCS of these two strings? Longest common subsequence. What is the LCS of EA? Okay. Longest common subsequence, Naikaj, in the current string that is given to you. All right, Himanshu and next, that's the correct answer. So for no, Himanshu, like why P? Like, okay, if it is a subsequence, then like it should, like here P is occurring at the end, but here P is before EA, right? So it can't be common, right? We need to have it after EA. All right, but in this case, it is not occurring like that. So, okay, the longest common subsequence, as correctly mentioned by Nix and Himanshu, you already gave the correct answer, and Shubham. Okay, so the longest common subsequence that we have is EA. Okay, all right, Himanshu, and what is that confusion? Do let me know. I'll try to sort it out. All right, see, when we are talking about longest common subsequence, so what is by subsequence? What we mean is both the strings should follow the same pattern. Okay, A B C is not equal to C B A. All right, or A C B. Even if the characters are same, okay, the arrangement of characters should be same as well, right? In subsequence, what is happening is that, when we were discussing about A B C B B A, we had, okay, and then we have if A B B C B A. If you are finding out the longest common subsequence, then by common what we mean is that it should occur in the same way. A, B, B, then we have C, C, then we have B, B, and A. All right. I guess this string, yeah. So it is that the pattern should be same. Like here, if it would have been a C, right? If there is a C here, sorry, if there is a D here, okay, and if there is not a D here, then you can't match it. Okay, the occurrence of the character, the arrangement of the character must be same. ABC is not equal to BCA just because the number of characters are same, right? The order must be same as well. That's what subsequence means. All right. So I hope it is clear now. Okay. So now, what is the longest common subsequence that we are going to have here is EA, that is 2. Okay. So now all right, thanks Himanshu for the confirmation. So, okay, now as you can see, if you want to insert or delete the characters, will you ever be deleting A or E from heap? Because we already see that EA is common in these two, and we need to make this string common to this string, right? So if you're trying to make it common, then it is very obvious that you are not going to delete common things, right? You are not going to delete common things. This observation is clear to you all, right? So as we are not going to delete common things, means what we are going to delete basically is we are going to delete the things that are not common. Okay, so what you will do is you will delete the things that are not common. Okay, for example H and P, and then you will try to insert things that can make it common. Okay, that can make it follow the same pattern. Like when we have deleted H and P, this string was EA, but as we observed that after adding P, this string became PEA. All right, and this string 1 was equal to string 2, right? So basically what I want you to understand this is, if you are trying to make string 1 equal to string 2, then you are not going to delete common characters. Okay, so now let's just move ahead. Yeah, so now what we are basically going, the operation was 3. Are you guys able to see this thing, that when you will delete the length of LCS from this string, and when you will delete the length of LCS from this string? Okay, all right, see, if you will delete P from second string and add H and P in string 2, all right, it is again going to take 3 operations, right? So basically we are trying to minimize the operation. So yeah, you can do it either way, but as they have mentioned that, yeah, you can do it either way, that is also correct. But that is also having the 3 operations in total, so that will give you the same answer. You can do whatever way you want, but then let's just try to keep it this way, that you should be like, you should first of all fix this thing, that from which string you are deleting and in which string you are inserting. Okay, once you are clear on this thing, only then, because you can't do deletion and operation on the same string, it will create confusion. Okay, so let us say we are performing deletion on this string and we are performing insertions on this string. Okay, now insertions from this string. Okay, now this was heap. Okay, so what is the size of this string? Let me take a new page. String size LP, LCS and difference. Okay, this string is heap. What is the size of the string? Very obvious, the size is 4. What was the size of the longest common subsequence between heap and P? It was 2. What is the difference? 2. The next string that we have here is P. Okay, what is the size of this string? 3. What is the length of the LCS? That is 2. What is the difference? 1. When you will add the difference, you will get the sum. Okay, how many of you are able to get this point? we are doing deletions from here and we are inserting the strings here, characters. Okay, like in the heap deleted h and p. Okay, then it was left with ea, and then we wanted to insert some characters from here, so we tried to insert p. Okay, because after inserting p, this both of the string are getting common to each other with a total length of 3. Okay, so is this calculation clear to you all? So basically what we are doing here is difference one is coming out to be m minus the size of the string that we have, LCS. Okay, and then the this is say the difference 2 that is coming to be, that is n minus LCS. Okay, now this difference you can take as number of deletions and this difference you can take as number of insertions, right? So is this equation clear to you all? All right, Rishabh, I can of course explain this table again. So see, the two strings that was given to us was heap and p. Okay, size of the heap is 4. The longest common subsequence between heap and p, it is having a size of 2. Longest common subsequence is ea. Okay, it is having a size of 2. So what is the difference between the size of the string and the size of the LCS? That is coming out to be as 2. Clear? Now this is p that is given to us. So the size of this p is 3, right? The size of the LCS was 2. Now when you will do the difference between size of the string and the LCS of the string, you will get 1. Okay, now when you will sum up the differences, 2 plus 1, you will be getting your answer as 3, and that is the answer to this question. Okay, so basically what I'm trying to say is the difference one, that is the length of the string minus the longest common subsequence, that is the total number of deletions, and then length of the string minus the longest common subsequence, that is the total number of insertions. So when you will add these two things, you will be getting the required answer, that is the minimum number of insertions or deletions. Okay, so please give me a quick plus one. So basically the answer is, you can simply return m plus n minus twice of LCS. And now we are very much confident about finding the LCS of the questions. Okay, so please give me a quick plus one or thumbs up in the chat section. Exactly, count first, delete, and then insert. That's correct, Shubham. So please let me know if there is any doubt. Thanks, Risha, for the confirmation. Let's just wait for a few more confirmations before I show you the code of this question. Thank you, Shubham. Thanks, Michaels. Okay. Thanks, Himanshu. All right. So this is the. It's okay. You can just keep on practicing. Okay. It's completely okay. And I would suggest that before jumping onto the DP concepts, make sure that your recursion is clear and you are good with logic building, mathematics questions. Okay. So once you are done with that, you can try to solve DP questions as well. And stay motivated, all right? Don't feel bad about it because everyone starts slow in the beginning. So just make sure that you are staying motivated and you are doing lots and lots of practice. And we have lots of practice questions and Geeks for Geeks, so you can try doing that. All right, everyone, this is the code of this question. What I'm doing, I'm simply returning the size of the string minus twice the LCS. And now we are very much confident about finding LCS. So this is the code for the LCS, okay? So, all right, okay. So you asked me to, recursion is basic of DB, yes, Manshu. So, all right, you asked me to share the codes. Okay, is this clear to you all? Is this code? Can I stop screen sharing for this code? Okay, thank you. So, so I will just thanks everyone for so many thumbs up. I will just share the codes, okay? Do we need all the codes or only for longest palindromic subsequence? Someone has asked me in the chat section. So for now, I'm sharing the code for LPS, and as that forms the parent for all the courses that we have. Thank you so much, Himanshu. I'm very happy that I'm able to deliver my thoughts to you all. No, like I'm sharing the code, the link of the code, I'm sharing it here. And I'm sharing the code for longest palindromic subsequence. It forms the parent to all of the questions that we have done. Copy and here I'm posting it. Okay, so that's the code for, and yeah, that's the code for it. Thank you so much, Himanshu, that the concepts are clear to me. And then let's just read some comments here. Alright, so yeah, it's really good and fair approach to learn DSA logic instead of stucking with single problem in one class. Exactly. So I might understand very well. And then we had some correct answers as well. Alright, so that was all about today's session. Please let me know if there is anything, any feedbacks, any compliments that you all want to add, or any suggestions for our sessions. Thank you so much, Shavon. Thank you, Nikaj. Yeah, homework problem. Okay, thank you, Shubham, for reminding me that. Yeah, I'm just providing you with the questions. Thank you so much for reminding me. So, let me just share the link with you all. So, this is the first question, link to the first question, and this is the link to the second question. And this is the link to the third question. Let me write down the problems as well in the board. My problems are basically okay, so second. You're most welcome, Himanshu. Okay, so let me write down the homework questions. Homework for tomorrow's session. Okay, tomorrow we will be discussing these practice questions. The first one is titular thief. Second is count ways to reach end stair. And third is longest increasing subsequence. Okay. Live session timing is every Thursday and Friday from 10 p.m. Alright. So, okay, everyone. That's all that we have for today's session. I hope your concepts were clear for this question, and I really want you all that please try to do these questions for the next session so that it will be interesting. Okay, thanks everyone for joining. Good night everyone, and keep up the hard work.